Welcome back. Here we'll be looking at more examples on integration by parts and the rules that guide us to figure the first function and the second function. Okay. Now looking at the rules guiding it. Okay. We said the integral of u dv. Any question, irrespective of the question given, how do you identify that? Okay, let the first one to be the u, let the second one to be what? V. Okay. Now the first rule says that if the first one, okay, says that if the product of the two functions, since we're given two functions, the integral of function u and v, okay, so you look at the function, the one that is not easily to integrate, that is you can't integrate it directly, will be your u, meaning u is equal to, looking at the two functions, u will surely be a function that is not easy to integrate, that is not easy to integrate. Why your v are function that are easy to integrate. So should, in case we are given two functions, the first thing you have to do is you look at it very well. Is there any function that is not easy to integrate? If you can figure out a function that you can integrate easily, then that function will be your u, and the one that is easy to integrate will be your v. Here you get example, when you have a question like the integral of x cubed log x to the base exponential. Now you want to integrate this using integration by parts. From the look of the question, it's very easy to integrate this. Yes, if you integrate x cubed, that will give us x raised to power 4 over 4. At the same time, it's very easy to differentiate it. If you differentiate it, that will give us 3x squared. That's for that. It's very easy to integrate. Likewise, very easy to differentiate. But if you are to differentiate this, it gives us 1 over x. But if you are to integrate it, it's not easy to integrate. Apart from using your standard techniques or using integration by part on it before you can integrate it. So since this part is not easy to integrate, this, then it means my log x will be my first function, which is u. And then this one that is easy to integrate, that's x cubed, will be my v. Okay, so I can say that u is equal to log x and then v is equal to x cubed. Okay, now to integrate that, I can say using the formula, we all know the formula, which is this. Using this formula to solve integration by part question, I can say is equal to uv. My u is log x. What is the v? V is this is the v. So to get my v, I'll have to integrate this. So if I integrate this, I have it to be times x raised to power 4 over 4, okay, minus the integral of v. What is v? That's still the same thing as x raised to power 4 over 4, okay, times du, that is differentiate log x. And if I differentiate log x, I have 1 over x. So that's times 1 over x, okay, which is equal to x raised to power 4 over 4 log x minus, okay, let's simplify what is there. This x eliminate one of this, then I'm left with the integral of x cubed over 4, okay, which is equal to x raised to power 4 log x, sorry, x raised to power 4 over 4 log x minus 1 over 4 the integral of x cubed. So if I integrate this, I have my final answer to be x raised to power 4 over 4 log x minus 1 over 4 times, when you integrate x cubed, that's x raised to power 4 over 4. So these two are what? Multiplying each other. Then I can say in conclusion is equal to x raised to power 4 over 4 log x minus x raised to power 4 over 16 plus c. Final answer. So the first thing you have to do is, when you are applying integration by part, you look at the functions given, which one is not easily to integrate. So if you can figure the one that is very difficult to integrate, you make it your u, and the one that is very easy to integrate, you make it your v. That is the first rule of applying integration, of identifying the first and second function in integration by part. Okay, now let's move into the second rule. Okay, rule 2. Okay, if there is no other function, what does that mean? When you're given just a function like the integral of log x, okay, look at that. When you're given the integral of log x to be exponential, you only have one function. How do you apply integration by part to that? So that's if there is no other function, or if you're given one function and you are to apply integration by part, what you have to do is you multiply that function with unity with 1. Okay, so it makes two functions like that. This will be this one, this another function. Okay, so you make your unity as your what? V. You make one v, then the function you're given remains what? U. So the case you're given one function, the function you're given will be what? Will be the first one, which is u. Then you multiply it with 1, that's unity, and your unity serves as the what? Second function. Another question, like, okay, what if you ask to find the integral of the arcsine of x? So to simplify this, what you do is you multiply. Since it's just a function, you multiply it with unity. So your unity serves as the second function, and the function given serves as the what? First function. So after identifying that, you can apply your integration by part. Here you get. So this is the first function, this is the second function. So let's take log x as example. So the integral of log x in base exponential times 1, this is the first function, this is the second function. Okay, using the formula is let's write it here. The formula is the integral of u dv is equal to uv minus the integral of v du. That is, the integral of the first and the second function is equal to first function integral second function minus the integral of the second function and the derivative of the first function. Sorry. Okay, now applying that formula, the first function is log x, the second function is 1. Now applying that, we have our answer is equal to the first function, that's log x base exponential, times the integral of the second function. If I integrate the second function is 1. If you integrate 1, I have it to be what? X, with respect to x, minus the integral of the first function, of the second function. The integral of the second function is still x, times the derivative of the first function. If you differentiate log x, you have what? 1 over x. Okay, now this eliminate this, then I'm left with, if this multiply this, it gives us x log x base exponential minus the integral of 1, which is the same thing as x log x base exponential minus, if I integrate 1, I have what? X plus c. Final answer. Therefore, the integral of log x to base exponential, or we call it the integral of ln x, is the same thing as x ln x minus x, or we can factorize it by saying it is x into bracket log x minus 1. Final answer. Now, the second rule of integration is telling us that should in case you are given just a function when you don't have any other function in your question, what you have to do is you multiply the function given with unity, and you make unity the second function, while the question given will be what? Your first function. So that's the second rule of integration by part. And lastly, we'll be looking at the third rule. Okay, now the third rule of integration by part, rule number 3. Okay, the first rule says that you look at the question, the one that is not easily to integrate will be your what? Will be your first function. While the second one says that if you have a function, you multiply it with unity. But what if both questions given are questions that are easy to integrate? Like at the same time, they are both questions you can differentiate. What I'm trying to say is you can integrate both of them. At the same time, you can integrate, okay, for example, you have the integral of exponential x squared exponential 3x. Looking at this, you can differentiate x squared. That will give us 2x. You can differentiate this. That will give us 3 exponential 3x. Likewise, we can integrate this. If you integrate this, it gives us x cubed over 3. If you integrate this, it's going to give us 1 over 3 exponential 3x. Okay, now we can differentiate both of them. At the same time, we can integrate both of them. Now, in this kind of situation, which one will I make my first function? Which one will I make the second function? Okay, so to figure out the first function and the second function, we make use of we have a precedent. You have an order you have to follow, which we name with an acronym called ILATE. ILATE. So you follow this order from the what? From the left. So the first function from the left becomes your u, and the second function will become your what? Your v. What I'm trying to say is, okay, look at this. This is inverse trig, inverse trig. The L is the logarithm. The A is the algebraic functions. The T is the trigonometry functions, trig, and the E is what? Exponential function. Since we are taking it from the left, so from the look of this question, I have two functions in it. I have the x squared, which is in form of algebraic functions, and I have exponential 3x, which is what? Exponential functions. We're told that the one that falls to the left is your what? Your first function. Okay, now since we have algebraic and exponential function, looking at it, the algebraic comes before the exponential. That's from the left. Since algebraic comes before the exponential, then it means x squared will be your what? Your u. That's the first function. And your exponential 3x will be your dv, which is the what? Second function. Okay, so that's how we figure out the one to make our first or second function if both of them are easy to integrate. Okay, let's consider this question. The integral of x arctan of x. Now, so how do we integrate this? I can say that can I integrate arctan? It's not easy to integrate arctan. Well, it's not easy to integrate arctan, but this one is easy to integrate this. It's easy to integrate this. So I use the first rule. The first rule says that if it is easy to integrate, if it is not easy to integrate, you make the one that is easy to integrate your v, and the one that is not easy to integrate your u. So from the first rule, I can say that this arctan is your u, and this x is your v. But using the third rule says that you make use of islet or islet. You get. Now from the look of islet, yeah, we have two functions. We have the inverse trigonometric function, and we have the algebraic function. But from this islet, inverse trig comes before algebraic function. So it means the inverse trig will be your first function, which is u, and the algebraic function will be your second function. So with that, you can figure out which one to make your first and which one to make your second function. So those are the rules that guide us to figure out our first and second function. Okay, so let's pick one example. Let's solve this integral of x arctan of x. Okay, now solving this question, I can say, okay, since this is the first function u and this is the second function dv, because we know we will integrate the second function. So I can say that by definition, we all believe the integral of the first function, okay, uv, the integral of u dv is equal to u v minus the integral of v du. But how do you get your v? To get your v, you have to integrate your dv, and then my dv is what? X. Okay, now applying that formula, I can say my answer is equal to u. What is my u? Arctan of x times v. What is v? V is the integral of x, and if I integrate x, it's going to give me what? X squared over 2. So that's x squared over 2 minus the integral of v. What is v? V is the integral of dv. And what is dv? Dv is x. So if I integrate my x, I have it to be x squared over 2. That's x squared over 2 times the derivative of my u. My u is arctan of x. If I differentiate arctan of x, that gives us 1 over 1 plus x squared. Okay, so I can say what is there is the same thing as, let's multiply together. That's x squared over 2, the arctan of x, minus this 2 is a constant, I can bring it out, minus 1 over 2, the integral of x squared over 1 plus x squared. Okay, yeah, that's correct. So we are to what? To integrate what is here. Now let's integrate this. Okay, now integrating that, I can say that is equal to x squared over 2, the arctan of x, minus 1 over 2, integral of into bracket 1 minus 1 over 1 plus x squared. How do I get that? I try to split this out so that it will be very easy to integrate using polynomial. Here you get, trying to split it out using polynomial, long division method of polynomial. But to check if that is correct, we can look at it from this angle to check if it is correct. If what is there is the same thing as this, we can say, okay, this is over 1. We all know that. So let's find the LCM. So the LCM will be 1 plus x squared. 1 in 1 plus x squared, that's 1 plus x squared, times 1 plus x squared. So that's 1 plus x squared minus 1 plus x squared and 1 plus x squared, 1. 1 times 1, 1. So this eliminate this. Then I'm left with what? I'm left with x squared over 1 plus x squared. So it is correct. What is z is the same thing as this. So integrating that, let me clean this. Okay, now let's integrate. So what is there is equal to x squared over 2 the arctan of x minus 1 over 2 into bracket the integral of 1 will give us x minus the integral of 1 over 1 plus x squared. Recall if you differentiate arctan of x, it's the same thing as 1 over 1 plus x squared. Okay, now if you integrate this, then it must give us this back. Okay, therefore I can say the integral of 1 over 1 plus x squared is the same thing as arctan of x. Final answer. So let's try to open our bracket. By opening the bracket, I have my final answer to be x squared over 2 the arctan of x minus 1 over 2 times x minus x over 2 minus 1 over 2 times minus arctan of x minus turn to plus, that's plus 1 over 2 arctan of x. Final answer. So that's what we call integration by parts, and those are the rules to guide you to figure out your first function and second function and your integration by part. Thank you.